Hi. So, we already did the syllabus calendar and expectations in a previous video, so we are not going to do that today in this video. This is the first instructional video I'm going to be providing. I want to apologize in advance if it's a little bit clunky. This is my first time doing this type of video. I'm not sure if today's lesson is going to end up being 1 or 2 or 3 or more videos. We will just find out, I guess. And I also want to apologize in advance if there is screaming or crying or dogs barking in the background. I live with babies and toddlers and dogs, and since I'm doing this from home, this is what you get. So we're going to go over Chapter 1 today. Chapter 1 is a lot of definitions, a lot of vocabulary. It is important to know this vocabulary in order to move on in this class, because it is the vocabulary we're going to be using the entire term. And then we're going to start with section 2.1. We will finish it, and we'll finish it in the next video. So this is where we are. Let's move on. Let's get started. So statistics. What statistics is it's a science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. Basically, it is just a way of compiling data and using that data to do whatever it is we plan to do with it. Usually we come into it with a hypothesis, an idea, and then we collect the data that we need in order to prove or disprove whatever it is that we are looking for. And the information that we are collecting is called data, or you could say data. It's your choice. I don't know which is right, which is wrong. I say both of them, depending on what I'm talking about. So it is the information that we're using to draw those conclusions and make the decisions. Data could be numerical or it can be non-numerical. And we're going to talk about those two different kinds, and we're going to be using both of those in some of the math that we're doing. In this course, we're going to be offsetting anecdotal claims, proving points, determining whether or not data is being used properly. And you're going to be able to apply a lot of what we're doing to all of the stuff going on in the world right now. So a population is the entire group that's being studied. So, for example, if we decided to do a study to determine whether or not the number of hours that you study correlates to the grade that you receive, if we wanted to study all of the RCC students, those RCC students would be your population. With a sample is a subset of that population. So for example, with that above study, if we decided to select 50 RCC students to use in the study because we can't really poll everybody, those 50 students would be our sample, and we would use the data we collected from them to infer about the entire population. So next, individual. It's a person or object that is the member of the population being studied. So one RCC student, that would be an individual. I think that one was pretty self-explanatory. So here's a scenario. Usually I hand out Post-it notes in class and have everybody answer how they would answer. However, that's not really possible in this class. So we're going to pretend. I'm going to grab some numbers and we are going to pretend. So you're walking down the street and notice that a person walking in front of you drops $100. Nobody seems to notice that the $100 has been dropped except you. You could keep the money without anyone knowing. Would you keep it or return it to the owner? So in previous classes, so last term, I got that 24 out of 26 students in that class stated they would return the money. Therefore, 92% of that class would return the money to the owner. This is considered a statistic. It's a numerical summary of the sample. So we just made a summary. We just took the data that we had and we just summarized what that data was. We didn't make any inferences. We didn't say anything about what we thought about it or any of that. So descriptive statistics describes the data through numerical summaries, tables, and graphs. So we have that numerical summary. We just described it, and that's that. So since we didn't draw any conclusions, this was descriptive statistics. So once again, 24 out of 26, or 92% of the class would return the money to the owner. So if we used this method, if we used some of our math to extend it to the entire population. Like, for example, if I said, therefore, I believe that 92% of all of RCC would return the money, that would be inferential because I'm inferring based on the data. So it includes a level of confidence though. So I could say, like, I am 95% sure, using the math that we have, I would find my level of confidence. I would be able to say I'm 95% sure that between 90 and 95% of the population of RCC students would return the money. That between 90 and 95 of all RCC students would return the money. So basically, I am taking what we got, our sample, and I'm applying it to all of RCC. That is inferential statistics. Suppose that the percentage of all students on your campus who have a job is 84.9%. The value represents a parameter because it is a numerical summary of the population. Suppose a sample of 250 students is obtained, and from this sample we find that 86.4% have a job. This value represents a statistic. Let me see here. So this one's a parameter. Represents a statistic because it's a numerical summary based on a sample. So parameter is a numerical summary of the population. Give me a second here. Let me get some. So parameter, population, statistic is based on a sample. So one way that you might be able to remember this is that that parameter and population both start with P, and statistic and sample both start with S. So statistic is a numerical summary of a sample. Parameter is a numerical summary of a population. Remember, the population is everybody. The sample is just those that we chose to talk about, or that we chose to ask questions of. Sorry about that. Okay, let's move on. The goal of inferential statistics is to use statistics to estimate parameters. This is our goal, and this is what we are doing in this class. All right. One thing I really like about doing this way, you'll learn I'm the queen of tangents, is that if you didn't get something, you could rewind it and watch it again. You don't have to ask me to repeat it, though I would happily do that for you. Let's move on. So the process of statistics, you are not going to be tested on this, on what that process is, but it's important that you hear what it is. First, you identify the research objective. So you need to figure out, what question am I answering? Because what's the point of collecting data if you don't know what question you're being answered? And what is the population you're studying? Are you studying RCC students? Are you studying the entire voting population of the U.S.? What are you studying? What's the population? Next, you can collect the data that you need to answer the question posed in step 1. So most of the time, it's really hard to conduct research on the whole population. So most of the time, you need to look at a sample, and you need to make sure you're collecting that sample correctly, that you're collecting that data correctly. Otherwise, your conclusions are meaningless. So I had to add this little thing about non-scientific studies, that they're based on convenience samples, because a lot of times you are sampling, this should be a lot of times you are sampling people who have a particular religious view. For example, if you did a poll on Fox News, you're going to have entirely different results than if you do a poll on CNN, because one of them is more conservative and the other is more liberal. So a lot of times your polls are not very reliable because of you're allowing it to be people who already might lean a certain way. 3, describe the data. So you need to make sure that you get an overview of the data. Like, for example, me saying 92% of my students would return the money. So you need to actually just, without making any inferences, just describe your data and then figure out what methods do I need to use. Last, perform inference. So using the math that you're going to learn in this class, you need to figure out which techniques are appropriate to use to extend the results beyond the sample to the population, and how reliable is your result. So that's it. This is our process. So the process we're going to use, I'm requiring you to remember these, but this is our important steps. Here's an example. Many studies evaluate batterer treatment programs, but there are a few experiments designed to compare batterer treatment programs to non-therapeutic treatments, such as community service. Researchers designed an experiment in which 376 male criminal court defendants who were accused of assaulting their intimate female partners were randomly assigned in either a treatment group or a control group. The subjects in the treatment group entered a 40-hour batterer treatment program, while the subjects in the control group received 40 hours of community service. After 6 months, it was reported that 21% of the males in the control group had further battering incidents, while 10% of the males in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeating batterer offenses. So I'm going to go through and ask some questions, and I want you to either pause it or at least think of your answers before I get to the answers, the actual answers. Because these are types of questions that might come up. So number one, what is the research objective? So think about what is the question that we are answering. So pause it and think about it, or at least just think about your answer before I get there. So our research objective is to determine whether those who are accused of battering their intimate female partners, that the ones that were in the batterer treatment program, whether they're less likely to batter again, compared to those that did community service. Next, what is the information that we need to answer this question? So think about that. So we had to have two groups. So we had a control group. We had those who were in the, did the community service were our control group, because those are the ones that, the regular ones. That's the regular way we dealt with it. And then we had those in a batterer treatment program. We needed to have two groups so that we could compare the results in the two groups. They're randomly put into the two groups. 6 months after the program ended, we determined the percentage of those who battered their intimate female partner again. Next, what is the data? What did we come up with? We need to organize the information that we got. How many people, how many were repeat offenders? So those in the control group, the characteristics of those in the experimental and the control group were similar. After 6 months, 21% of those in the control group battered again, while 10% in the treatment group battered again. Notice we did not make any conclusions. All we did was say, this is the data we have. The next step is where we're going to make our conclusions. So drawing conclusions from the data. So we extend the results of the 376 males in the study to all males who batter their intimate female partner. So we decided that our sample was a good representative of the entire population of those who've battered before. And so now we are saying that those who battered their female partner and participate in the treatment program are less likely to batter again. So there we go. Now's the part where I would ask for questions, but obviously you can't ask me those questions right now. Feel free to ask them in the forum or send me an email if you have questions. Some little bit more vocabulary here. Variables. The variables are the characteristics of an individual within the population. So, for example, if I'm deciding whether people who are left-handed get better grades than those who are right-handed, the characteristics I'm looking for is whether somebody's right-handed or left-handed. That would be my variable. Or here, if everyone had the same height or all plants grew exactly the same, we wouldn't need to look at more than one person or object to know information about the entire population. So we wouldn't need to do any statistical inference. Qualitative or categorical variables. I use both words, categorical and qualitative. So these are based on some attribute or characteristics. So these are generally non-numerical, or they're numbers that don't mean anything. So gender, zip code, hair color, birth date. These is like, the numbers are numbers you don't usually do math with, is the way I put it. Like zip code, you don't do math with zip code. It's just an identifier. Gender, hair color, birth date. Most of the time, birth date, unless you're talking about how many days younger than somebody you were, birth date is generally not something that you use as do math with. So that's qualitative or categorical, is something you don't do math with. Quantitative data. It's numerical measures of individuals, can be added or subtracted, and provide meaningful results. So these are numbers that you do math with. Temperature, number of days the students have studied, height, weight, things like that. Those are numbers that you do math with. So let's do a quick test of this. So think about it before I give the answer. So researcher Elizabeth, some name I can't pronounce, and others studied factors that affect the eating habits of adults in their mid-30s. So this list right here are variables that were considered in this study. So think about, are these qualitative or quantitative? Remember, qualitative are either numbers you don't do math with, or they are not numbers. So nationality. So nationality is not a number, so it's qualitative. Number of children someone has. Now this one is something that it can kind of go both ways depending on what you're looking at, but it's basically quantitative. Household income in the previous year. This is also quantitative. Level of education. Now, depending on what you're using it for, it could be one or the other. I say qualitative here because I'm thinking high school, bachelor's, master's, PhD. Those aren't necessarily numbers. However, you can make an argument both ways. Daily intake of whole grains measured in grams per day. I think I have the wrong answer on this one. It says qualitative. I am saying it is quantitative because it is measured in grams per day. Sorry, I have the wrong answer on there. Before I upload the PDF onto my Open Math, I will fix that one. Okay, so discrete, and we are almost done with this. Discrete and continuous variables. So discrete variables are quantitative variables that have either a finite number of possible values or a countable number of possible values. So things would be, it can't take on every possible value between any two possible values. So for example, number of students in class, how many TVs sold in a week, number of red marbles in a jar. So if I were to plot these on a graph, it would be dots. So it would be because every value in between isn't possible. So like say I was selling t-shirts, that every t-shirt I sold was $5. You're not going to earn $5.50. You're not going to earn $75. So for one t-shirt, that would be $5. For two t-shirts, that's $10. 3 t-shirts, $15. It's not going to take on every value in between. It's going to be an exact number, and then it's going to jump to the next one. I can't fill in the line like that because it will never be $7.50. I hope that made sense. Okay, so, whoa, that's not what I want. Okay, so continuous variables. Sorry about this. So continuous variables are quantitative values that have an infinite number of possible values that are not countable. Every possible value between two values, every value in between two values is possible. For example, height of students. When a student grows, someone grows, they don't go from 4'8" to 4'9" without hitting every value in between. Time it takes to get to school. You're going to hit every value in between from like if it takes me a half hour to drive to school, I was still driving at the 25-minute mark. I was driving at 28 minutes. I was driving at 29 minutes, 30 seconds. Distance traveled. You don't jump from 1 mile to 2 miles. You have to travel every distance in between. Now, weight of a baby at birth. This one's kind of weird. I'm thinking more of the baby starts weighing basically nothing and hits every value in between until it is born. So it has to be like hair length. When your hair is growing, it hits every length in between. So on this graph, you would be able to draw that continuous line. So you draw the line without lifting your pencil. Discrete variables, with discrete variables, you have to lift your pencil in between the points. Continuous variables, you don't lift your pencil. I hope that makes sense. Okay. Okay, so we're going to classify each of these as discrete or continuous. So this is also that same study. So the number of children someone has, is that discrete or continuous? Oops, I'm having issues, I'm sorry. So that would be discrete because you're not going to have 1.5 children. Household income the previous year, this one's a weird one. I say it's continuous because you had to make every dollar in between. Because if somebody works an hour and 15 minutes, it's a different amount of money than if they work an hour. Daily intake of whole grains measured in grams per day. This is also continuous because you're going to have to eat everything in between. You don't just eat 1 gram and then 2 grams. I mean, I guess you kind of do, but it's kind of shaky. Like I already said, length of hair, height somebody reaches, distance driven, things like that would be continuous, not lifting your pencil on a graph. We're almost done, guys. So levels of measurement. So this one right here, I think I'm going to stop and I want to do a second video on this. I know this is only 3 videos long, but I think I need to give you a different video. So I'm going to stop this one for now and I will pick this up at this point on my next video.